So for the first example, so a mass weighing 2 pounds. I'm going to pull out some key terms here. 2 pounds stress a spring 6 inches. At T0, a mass released from a point 8 inches below equilibrium position, upward velocity 4/3 feet per second. And we're going to find the equation of motion. Equation of motion, that means the equation x of t. Okay, x as the position at the time t. And this one is involving the pound, the foot, the inch is in the English system, right? English system. So now from these pieces, we just pull out information. The mass, which is 2 pounds, the m, um, the m, the mass would be the weight divided by g, divided by g. Okay, and in this case, the m is 2 pounds divided by the g. The acceleration for the case of the English system is what is it called, like 32, right? 32. So then let me see. Um, yeah, so this gonna be 2 over 32. Okay, and the unit is, what's that? Slug. Okay, 1 over 16 slug as a m. And what else that we know? The mass 2 pounds stretch a spring 6 inches. So the other part is from the spring. So to find the spring constant from the Hooke's law, F equals K times X or times S. We can use either one at this point. So 2 pounds equals the K times X 6 inches. We're gonna change everything into the what do you call, the same system, the same units in the English system. So 6 inches means 6 over 12 foot. So 6 over 12 or 0.5. So then the K equals 4. Okay, K equals 4 for this case. And the unit is pound per foot. Okay, pound foot. So we get K, and what else that we have here? We have the mass is released from a point 8 inches below the equilibrium position. 8 inches, the unit, this is a position unit. So x at 0, below means positive, plus sign below, so go further down from the equilibrium position. 8 inches, 8 over 12 feet, foot. Okay. And then the other part with an upward velocity. Upward means negative side of the velocity, or the x prime at 0. So negative, the unit is already in foot per second, 4 over 3 foot per second. Okay, from this, do you guys have question before I move on to put together as the the differential equation? No question. Okay, so that means this one, no damping force, no external force. The model is x double prime plus the k over m. So we can write the original one like m x double prime from the Newton's law plus the k times x. This is from the Hooke's law equals no external force. Okay, and since the m that what we found is 2 over 32, which is 1 over 16. So this is 1 over 16, x double prime, plus k, which is 4. 4 times x equals 0. Then from this equation, with the two initial conditions, just rearrange to get ready to find the solution. So we work on the x double prime plus multiply 16 all the way to get 64, x equals 0. And as we check the omega square, which is the k over m, right? The k is 4, the m is 1 over 16, which come back to 64. That means the omega is going to be 8, just for our reference on the notes on the side there. Now, to work on this differential equation with the condition x at 0 equals, let me write it 8 over 12, which is, um, let's see, 2 over 3, right? 2 over 3. Let me check real quick. So this is 2 over 3, and this one is negative 4 over 3. So 2 over 3 x prime at 0 equals negative 4 over 3. And then after you get this differential equation, now back to the same process of what you did in chapter 4 with the non, this is the homogeneous, which is nothing to do with the XP form or the pattern to get, the particular solution. Okay, it's simple for the undamped free undamped motion. Now, quick way to solve, to get m squared plus 64 equals 0. So m equals plus minus 8i. Therefore, the solution, the general form is x at t equals the c1 cosine 8t. X is a function of t, right? Plus c2 sine of 8t as the general solution. And then use the initial condition to find the c1 and c2. So for x equals 0, so we have 2 over 3 equals the cosine at 0 is 1, so we get c1, and sine at 0 is going to be 0, so we get c1 is 2 over 3. And then x prime, let's put a note here, for x prime at t is negative 8 c1 sine 8t plus 8 times c2 cosine 8t. X prime at, I'm going to put here, t at 0, x equals, and the x prime, let me clean up real quick. So for t equals 0, and the x prime equals negative 4 over 3. Sine at 0 gonna be gone, cosine 0 gonna be 1. So negative 4 over 3 equals 8 times c2, or c2 equals negative 1 over 6. Okay, negative 1 over 6. So we get two initial conditions, no, two parameters as c1 2/3 and c2 as negative 1/3. So then the equation of motion is x at t equals 2 over 3 times cosine of 8t minus 1 over 6 times sine of 8t. And now, to analyze it more, well, this problem doesn't ask you to do more, like, or ask you to write in the alternative form. But if we want to analyze more, or in the case of the question asks for the period or the frequency of this motion, so we can go further by from the what do you call, the alternative form, which alternative form of the solution, which is in the form of the x at t equals the a times sine of omega t plus the phi. Okay, a is from the square root of c1 squared plus c2 squared. And from what we got, c1 is negative 1 over 6 squared. And no, wrong one. This is 2 over 3. So quantity 2 over 3 squared, and then the C2, which is negative 1 over 6 squared, and take the square root, and we will get, real quick, that's 4 over 9. Well, I look at my notes, I'm cheating. So my A is square root 17 over 6, just to keep it short, which is about 0.69 unit is in feet because we convert everything in the same unit form. Okay, and the angle phi is the inverse tangent of the value C1 over C2. It has to be in this pattern. So that means C1 is the coefficient of the cosine. C2 is the coefficient of the sine. As you notice, this is the same pattern as when you work on chapter 4 with the homogeneous solution, cosine first and then sine later. C1 for the coefficient of the cosine, C2 for the coefficient of the sine. Okay, so the phi is the inverse tangent C1, which is 2 over 3 divided by negative 1 over 6. This is another sensitive part. When you look for the inverse tangent usually for the trick, the tangent of an angle theta is y over x, right? It's y over x. If you recall that pattern, that means the side of the tangent will be from the side of the y and x, or the quadrant that is located. Okay. For our case, the tangent, the numerator of the argument here, the sign is positive. This, the sign is negative. The angle is in what quadrant? It looks like the y is positive, the x is negative. It's going to be in quadrant 2. Okay, that's the sensitive part that I was talking about. Okay, when you put in the calculator, it will give you the sign as, I believe, is negative sign. Negative sign. Okay, so you're gonna let me if you have the calculator, you can work on that, and the angle gonna be not in degree, it's gonna have to be in radian. So the phi that you get based on the calculator gonna be negative 1.326, I believe. Okay, you can verify this number later. If you get different number, let me know. So then the angle that we really look for, so the angle phi in quadrant 2. Okay, so phi will be pi minus 1.326, because this gonna be the x at t equals the a, which is the square root 17 over 6, or about 0.7 foot, and multiply by psi, the omega, which is 8t plus 1.816 radian. Okay, so the period, which is 2 pi over 8 or pi over 4. So it takes the pi over 4 to complete one cycle. And this is the period. And the frequency is the reciprocal of the period, which is 4 over pi.